This is part 3 of the tutorial about history analysis in RayJack ONE. In this video we will learn how to inspect the paths of a ray tracing simulation in the grid viewer. To this end, we study the ghosts of a simple telescope toy model. We initialize the simulation with a maximum number of 2 splits. As the glass for the lenses, we select shots NBK7. We define 2 lenses and call them lens 1 and lens 2. The housing of the telescope is defined by 2 cylindrical surfaces and 1 planar ring-shaped surface. For the housing, we define a reflectivity of 1%. Note that the commands in line 53 and 54 allow to set the properties of the whole housing at once, by addressing all physical objects, the names of which start with housing dot. Behind the telescope, we define a planar screen object and equip it with an irradiance detector. The source is given by a collimated grid source at a wavelength of 550 nanometers. The source is rotated by 3 degrees. We define a viewer object and set a cut plane at 0 such that we can look into the geometry. So this is how the telescope looks like, with the source on the left and the screen on the right. We define a ray tracer and start the ray tracing simulation. It takes a couple of seconds. After ray tracing, we display the irradiance distribution measured by the irradiance detector. We select a logarithmic scale type of the color bar such that the ghosts become visible although they have a weaker irradiance compared to the nominal light. Running this section of the code visualizes the irradiance. We can see the irradiance of the nominal light and several ghost patterns. So this script is the starting point. Next we will see what changes have to be done to the script such that we can perform a path analysis. First of all, we need to tell the history detector to record the interactions. This can be done somewhere in the script, but it has to be done before the ray tracing starts. So I add another line with the command history.settings.recordPaths equals true. In a later video about the history settings, we will learn what this setting means and what alternatives there are. For the moment, it is enough to know that with this setting, the history detector will track the interaction data that is needed for the paths analysis. Next, we relaunch the script from start to line 83. After the ray tracing has finished, we can inspect the paths with the following commands. We write history.getPaths.gridView. So now the ray tracing is over and I run line 85, which opens a spreadsheet showing the paths. In this spreadsheet, every line corresponds to one path. Column B shows the path ID starting with 0. Columns C and D show the number of rays and their total flux that correspond to the given path. Columns E to I show some integer numbers that characterize the sequence. For example, the total number of hits, the generation of the rays that belong to this path, the number of split events, the number of scattering events, and the number of total internal reflections. Finally, the columns after column I show the individual interactions of the sequence. Every interaction is displayed by an interaction symbol together with the name of the interacted object. For example, the sequence starts with the creation in the grid source. Then comes the transmission through the front of lens 1, the transmission through lens 1.back, the transmission through lens 2 front, then the transmission through the back of lens 2, and finally the absorption by the screen. For a list of interaction symbols used in this view, see the user manual and the chapter Path Analysis, and there is a section Inspecting Paths, where you can see a table with all existing interaction symbols. Sometimes we want to visualize the rays that belong to a given path. To this end, we can right-click on some path, for example the first path, which is the nominal path, and then we can pick the top entry of the context menu to open a new system viewer that displays the rays of that path. I use a cut plane to look into the geometry, and we can see the nominal path. We can also check some other path, for example this one. And we can see that this path involves some internal reflections by the second lens and a couple of reflections by the housing. So we have used the command history.getPaths.gridView in order to display the paths. For completeness, I would like to add that there is a shortcut notation for this command, which is just typing history.gridView. This is just an abbreviation for the same command. Finally, it is also possible to trigger the display of the paths by expanding the global detectors node in the optical system tree. Go to the history detector and then either double-click on the path symbol or do a right-click and then show in grid viewer. In the next video, we will learn how to sort and filter paths.